Welcome to the third video for the first problem for the second exam. In this one, we'll use the shear functions and the shear diagram to determine the moment equations for our moment diagram. Now that we have the shear functions from A to B, from B to C, and from C to D, we can determine the moment functions. The moment from A to B, of course, the moment function in general is going to be the integral of the shear function. We're very lucky in that this is a constant and so is this. So our moment from A to B is a function of x1, again, starting x1 at A, starting x2 at B, starting x3 at C. We're going to get that it is equal to the shear, which is negative 9 kip times x1 plus some constant integration that I'm not even going to write down, because we know as a boundary condition that at free end like A, we're going to have a 0 for the moment. So the moment better be 0 at A, so we better not have a constant integration in this function. Similarly, from B to C, we're going to want to follow the we're going to have 9.1 kip times x2, but we are going to have a constant integration. This one is going to be negative 3 times negative 9, so whatever the moment is at B, because it turns out that the moment at B is the moment at B. We don't have a discontinuity in moment because we don't have an applied moment. So that'll be minus 27 kip feet, because that's what the moment function from A to B is going to tell us. Negative 9 times the 3 feet from A to B is going to give us negative 27 kip feet. And then finally, for C to D, we're going to have to explicitly do that, and we're going to have to consider the moment induced by the moment from A to B if we plug in 2 to this. So if we do that, we're going to, well, let's see, integral of our shear function from C to D is 9.1 kip minus 2 kip per foot times x3. Integrating that, we're going to end up with 9.1 kip x3 minus 1 kip per foot times x3 squared plus some constant of integration. And this constant of integration has to be sufficient that the moment at C is equal to the moment at C. So plugging in 2 for this, we're going to end up with 18.2 minus 27 kip feet, and that's going to be 8.8 kip feet, negative 8.8 kip feet. So that's going to be our constant integration for the moment from C to D. So when we draw this all out, I mean, this is going to be a quadratic. Well, let's write it all out. And again, I'm going to put the constant of integration first, negative 8.8 kip feet plus 9.1 kips x3 minus x3 squared times kips per foot. So now let's draw this.